So now let's talk about load balancing with Docker networks. So we'll do basically load balancing with some Nginx or HF proxy, but Docker also has a load balancing technique, so which we will see. Okay. So we'll understand load balancers, various algorithms, what are proxy servers, reverse proxy servers. Okay, how to use Nginx and HF proxy as reverse proxy, and what is DNS round robin load balancing technique. Okay, so what is a load balancer?
Distributing the incoming traffic uh,
Yeah.
to
So it
different
is just
multiple
a
users.
service that distributes the incoming traffic to various backend services, right? Or servers. Okay. So those set of servers are also known as server farm or server pool. So where the incoming traffic will be split, across all the servers. Okay. So it's just act like a single entry point to your complete application, load balancing the traffic evenly. Okay. Okay, so we know why load balancers are required. Okay, in case of servers or it can in case of containers. Okay, in case if you have a single container for your application and if your number of users increases, so what will happen to the performance? The performance will be degraded, right? Because now a single container has to process all your requests. Okay, but what if I have multiple containers handling your request? Okay, so instead of one container, I have now two containers. Okay, containers like C1 and C2. Okay. So of course I can split the traffic like 50% I can forward it to C1, 50% I can forward it to C2. Okay. But who is going to split this traffic? So there should be a load balancer, right? Right, guys? Now it is up to you where you run your load balancer. Okay. So will you run it outside your Docker host? So like you have ELB service. Okay. So where you can create application load balancer. So that can forward the traffic to two different instances. In fact, you can also, create a load balancer container internally to your Docker host and have that container forward the traffic to two different containers. That is also possible. Okay. So we will see that. A load balancer, we know that it sits in front of all your servers or your containerized based applications, and then it can split the traffic. Okay. So according to your load balancer configuration, right? So load balancer runs on a variety of protocols. Okay, in fact, your load balancer also has, this feature of checking the targets. Okay, so whenever load balancer receives the request, it usually forwards the request to the targets. So target means the group of servers, for your load balancer. So whenever load balancer just receives the traffic, so it is going to send the traffic to all its target. Okay, so now load balancer also has this feature of checking the health of your targets, health of its targets. Okay. Let's say there are two containers, C1 and C2, serving like its targets. Now, whenever it sees that C2 container is not available anymore, so what it will do is it will send the traffic to other instances. So it will stop sending the traffic to the the container or the server which is currently down. Okay, so how this is, your load balancer is going to decide whether the server is or the service is down or up, guys. So it will run some
Maybe polling.
health checks. Okay. So health check in the sense it can be anything. So it can be talking to the application over its IP address, call and port. Okay. So it will try to reach the container or the server on the specific IP address and port. Or if the server is having some endpoint like slash health, sometimes you will see slash status or slash health health something like this. Okay, so if it tries to it will try to check that endpoint, it will try to reach that endpoint. So let's say it will simply do curl or probably like ping. Okay, to see whether it is able to reach that instance or not. If it is not able to reach that instance even after trying for a couple of times or 5 times, it is going to remove that particular target from its load balancing. Okay, so load balancer also has these features. In fact, if you have tried to configure ALB, right? So you would have seen this health checks as well. Okay. And what are the other use cases of having a load balancer in front of your servers? The first thing is your traffic will be distributed. Okay, you'll have high availability. Okay, because if you have a single service, so there are chances that that service might go down. So with increased user traffic, but if you have multiple services, all the services receives equal amount of traffic, which means traffic will be split across all the available targets. Okay, and you have health checks to determine whether the instances are healthy or not. If they are not healthy, basically the traffic will be cut off. Okay, and so auto scaling is also there, which will it's not required as of now. So improved load times, reduce server load, and the other thing is TLS termination can also be possible in case of using load balancers or reverse proxies. So can you guys tell me what is TLS termination?
The TLS is
After
going
entering
from
from
the LB.
LB, the security gets, I mean to say, termination.
Yeah. So TLS termination means you can say, so SSL termination. So this is where your encryption gets ended here. It gets stopped. That's the final point. Okay, so which means if I say TLS termination or TLS is terminated at LB, so which means till LB, till its input, the traffic is all encrypted. It is always HTTPS from outside. Okay. So anyone who has to talk to LB, so they need to use HTTPS protocol only. But from LB, okay. So here LB means it resides within your network, right? It is in your control. Okay. So till LB, you will allow HTTPS traffic. But after LB, okay. So if you want to forward the traffic to any instances, it is always HTTPS because you ended the encryption or TLS at LB. Okay. Now there are various advantages of terminating LB, terminating TLS at LB or reverse proxy. Okay, so the advantages is, okay, so once you terminate here, you don't have to worry about inserting certificates into your applications. Okay, because TLS is terminated here, and everything within your servers is a plain traffic. So you don't have to worry about creating certificates, rotating certificates. In case if any certificate is expired, you'll just reconfigure it here in LB. You won't, touch anything at your app level. Okay. And also data communication will be faster because, the traffic between LB and app container is HTTP only. So there is no time wasted for encrypting your traffic. Okay. In case if you have to terminate TLS here, so which means even the complete traffic till your application is all HTTPS, you need to configure your TLS certificates here and all that stuff, right? Got it?
Yes.
Okay, so that is the use of TLS termination. You'll actually terminate the TLS at load balancer only. Okay. Now there are two forms of load balancers. So one is hardware based, the other is software based. So hardware
Yeah.
based means,
Sorry, Vikram. Can you please go to previous slide? No, that diagram one. Yeah. Yeah, yeah.
uh,
Yeah. So you are saying that the incoming traffic is getting end up at LB. Encryption is getting terminated at LB. But what about the traffic moving out of app container or DB container?
till here,
Yeah. Yeah. This direction.
same HTTP only.
So it LB converts do the encryption task.
Yeah.
when it gives to the clients.
Correct.
Okay.
So
So
Vikram,
one
there is
more
no.
thing, from the network perspective, so LB should be, I mean, if these two containers, app container and DB container and different networks, I mean,
Hmm.
should LB be part of both networks?
LBB part of see that's why it is ALB. If you see ALB, it sits outside your Docker host. Okay, since LB cannot reach directly to the container, so what I did is I used port mapping.
Okay.
Okay, so on the host level, it is running on 80 and this one running on 81. So LB try to reach the host port. So for this, it need not concern about the networks in which the containers are running because already the containers are port mapped onto the host. So you directly reach the host.
Right, understood. Yeah.
Okay. So someone is
So even
asking
though the
something.
two containers, app container and DB container and different networks, so because we do some kind of a configuration in LB, it segregates the traffic and sends to one of them.
Yeah.
Okay, got it. Thank you.
So Vikram, there is no like security, TLS security inside the network, like
Yeah.
inside the
Inside the
network.
network, you don't have. So that's why, you have this tool called Istio, a service mesh. Okay. So we actually use this in Kubernetes. So the reason why we have this service mesh is, so in case in Kubernetes you have various pods. Okay, I'm saying this for the microservice one and this for microservice two. So the traffic between this pod to pod is again plain traffic. Okay, just like what we have seen here.
Okay.
Okay. Now what if I have to enable TLS between these two? So if I have to enable TLS between these two, I need to create certificates, insert them into individual pods. And if these certificates are expired again, I need to modify or rotate those certificates. So it becomes very difficult for the application owners to understand TLS and know how to configure, or there are a lot of challenges, right? So that's the reason why we have this tool called Service Mesh. So what it will do is it will actually enable mutual TLS. Okay, mutual TLS means TLS is enabled in both ways. Okay, so this tool is responsible for inserting the certificates, rotating them, revoking them, so that you have mutual TLS communication without any additional configuration done to those container images or pods.
Okay.
Okay.
Like if like we have the client contacting any container, right?
Hmm.
Like we see in other classes. So in that we have the TLS communication. So that means that Docker client is communicating from outside the network, right?
Correct. Yes.
Uh,
Anywhere if you see certificate, uh, just remember that the server is expecting a TLS communication.
Okay, so if I'm using enterprise network, there is no certificate thing. I'm just communicating directly to the servers
No, it's
using.
not like that. It's not like that. It depends upon which protocol you are using. If you are using HTTPS, definitely there are certificates involved. Okay. Again, see if it is publicly given certificate, given by some known authority, right?
Mm-hmm.
So you don't have to know about the server-side certificates and all. So you can just hit the server on HTTPS. But if the certificates are generated using self-signed certificates, then probably you might require the public key of CA.
Yeah, the PKI thing, right?
Yeah. So it all depends upon who signed those certificates.
Okay.
Okay, that's the reason why when we are using client, right? So usually client has its own key and certificate. So, but we also used CA's certificate, right?
Right.
Okay, why this additional thing is required? Because, the server certificate is signed by the same CA.
Yes. Public.
Okay, it is not signed by some public CA to trust it. So that's the reason this additional check is required.
Okay.
But anyway, the containers are not exposed to the public, right? Or to the internet.
Yeah, that is true. But still, why to take risk? So why can't we just use mutual TLS when you have the option to enable it?
Okay, so mutual TLS is the other way to use TLS with certificates, right?
Correct. So, I don't want to show this, but that's fine. So if you search for Istio or just search for Envoy proxy, okay? Just understand how this is running. If you see, many people actually use it. Okay, so it has this advanced load balancing, MTLS. I don't know if it is there here or not. You can just go through this,
Okay.
or else, just search for Istio MTLS. Okay, secure application communications, mutual TLS, and Istio.
I think we use
Okay, you
HA
can
proxy.
see, okay, how mutual TLS works. Enable mutual TLS. So once you have Istio installed, you can enable mutual TLS. Just go through, probably just click on images and see, that is where you'll have good understanding. You can see pod A is talking to another pod, using envoy proxies. These envoy proxies, uh, which one is giving? So this envoy proxy is actually giving that. Okay, I think this is a good link. You can see here, you have envoy proxy. Okay, so that is giving you MTLS communication between two different services and all. Okay, it's not like you can use envoy proxy only in Kubernetes and all. You can also deploy it on a server and see how that envoy proxy works.
Okay, server containers, anything
Anything, because if
inside
you
the
go to
network.
its download page, you can download it. See, install envoy proxy on Ubuntu Linux. You can run it as a Docker container, or else when you install Istio on Kubernetes, so this envoy proxy gets enabled. Okay, see here, you have all commands to install envoy proxy.
Okay, so it's just automating the way of creating and
So
granting
what
the
it does is
certificates.
that server will automatically create certificates which are short-lived, and automatically these certificates are renewed uh, automatically by envoy proxy.
And this thing is done by DevOps, not PKI, right?
Yes, because these are all automatically signed by envoy only. Um, it is not done by PK. I think you can also use other certificates. It's not like envoy should generate its own certificates, right? So if it has access to some service, it can also fetch the certificates from there, okay, and then use it. Okay, it depends upon the organization requirements, right?
Yeah, yeah.
Okay.
Mhm.
Now coming to the load balancers, you have two types. You have hardware-based load balancer and software-based load balancer. So hardware-based load balancer will have specialized hardware, okay, with specialized processors and running their own, custom load balancer softwares. Like if you take the case of F5 or Cisco ACE, okay, so these are all hardware-based load balancers. They provide you the hardware as well as the custom software, installed on those hardwares. So these are hardware load balancers. And you have software load balancers, okay, so which generally run as a software package on a hardware. Like you have Nginx, HA proxy. So they do not have any dedicated hardware, right? So you create an EC2 instance or any server, and then you install Nginx or HA proxy. Okay, so they are, software load balancers. So you also have cloud load balancers, which are fully managed load balancers by any cloud. Okay, like in case if you see the AWS, you have application load balancer, so which ideally handles layer 7 protocols, network load balancer, which handles layer 4 protocol like TCP, and you have classic load balancer, which handles both layer 4 and 7. Okay, and the newer edition, which is gateway load balancer, in case if you are deploying any third party, appliances, okay, like firewalls and all. So this the gateway load balancer comes into the picture. I never personally used gateway load balancers yet. Okay, so these are cloud load balancers. And now coming to the load balancer algorithms. Okay, so let's say there are three different servers. In front of it, you have a load balancer. So how the load balancer can send the traffic to its targets? Okay, so it can be round robin. Okay, round robin means it will distribute the traffic in a circular fashion. Like it will first serve the first one, after that second one, next third one. Again, it will come back to the first one. So this is round robin. Okay, the other one is least connections. So first it will see, how many connections are, already active to the backend instances. Let's say one has least number of connections. Then load balancer will forward the next request to this one. Okay. Least response time is also there. So in this case, load balancer will check which of the, servers, backend servers is giving lower latency or response time. Then it might forward the next request to that particular server. It can be random. Random means load balancer will randomly send the traffic. IP hash. So IP hash is one feature. It is also there in Istio. You can also configure it in many ways in other services. Okay, what is IP hash is? So, let's say, you know, I'm connecting from my home network. So I have a public IP address, some public IP address. Okay. Now, if I try to reach the load balancer from my own device, so what this load balancer can do is load balancer can create a unique key. I'm just talking about, this unique key and all. I've just created the term. Okay, so it might create a unique key using your information like IP address of your machine or your location or something like this. Okay. Now, first time what it will do is it will use any algorithm and forward the traffic. Let's say it has decided to send the traffic to 2. Okay. Now, the next time, if you request the or if you try to access the load balancer, okay, it will again calculate the hash value. Okay, or it will try to it will try to calculate the unique key. And if it finds that this unique key is already known to it, then what this load balancer will do is it will forward the traffic to second instance only. Okay, so if you know about sticky sessions, you know what are sticky sessions, guys?
Yeah,
So what are sticky sessions? Let's say if
basically maintains the connection.
maintains the connection to the same server. Okay, let's say I requested some data from the backend, so it has to go through load balancer. So load balancer, let's say, send the request to the one. So the next time, if you get disconnect and disconnect again and send the data to LB, LB will try to forward the data to the same first instance like previous time. Okay, so it does that by maintaining your client information. Like it might read your IP address and store it. The next time if the request comes from the same IP address, it will forward the request to the same server like last time. Okay. Got it, guys?
So all load balancers have this kind of configuration, or
So it depends. You need to check what all algorithms that particular load balancer is supporting.
and if at all it has, we need to do some kind of a
And
configuration.
you just have to enable IP hash. Okay. In this case, you should also have configuration to invalidate that hash value. Let's say after one day, I'll invalidate that. I'll delete that entire information. Okay. So the next I'll again start from scratch. If a device is connecting again, it is again a fresh request. Okay.
Understood. Yeah. Thank you.
Now proxy servers. So proxy servers are another servers, so which are intermediate, okay, between your, you and the internet. You can also say between your client and your server. There are servers that sits in between your client and the server. Okay. So both proxy servers and load balancers are, key components of the client server architecture. Okay, so you can put the client server in two places. Okay, you can put it near to your client, or it can be near to your server. Okay, so that makes it either forward proxy or reverse proxy. But remember, proxy means it is a server that sits between you and the internet, or the client and the server. Okay, now let's understand what is reverse proxy. So this reverse proxy, it is for the users. Okay. So ideally reverse proxy is towards, it will be in your, what do you say? It will be towards your server. Okay. Or your application. Got it. So if you take this as the internet, right? You set the reverse proxy in front of your web server. Okay. Now I'm just talking about only one server which is running your application. So this can be multiple instances. Okay. But this reverse proxy is put in front of your complete application. Okay. So now whenever a client sends the request, they won't directly send to the application. They will directly send to the reverse proxy. You will configure it in such a way that the traffic is received by reverse proxy. Got it? Let's say I have a DNS name. Okay, this DNS name, instead of mapping it directly to the instances, okay, you need to map it to the IP of the reverse proxy. Now, entire request will come to the reverse proxy. Now, what is the advantage of using reverse proxy? Why should I put a reverse proxy in front of my application? Why can't I simply ask my user to directly connect to my web server? Hmm? Okay, there are multiple reasons. So one is, this reverse proxy hides the details of how the servers are set up or how your application is running, because reverse proxy receives the data, initial connection, and it is going to send the connection to the backend servers, which means user will not know, how many web servers are running, where exactly your applications are running. Okay, so it is to hide your topological design of the servers. The second thing is caching mechanism. Okay, so what is caching mechanism? Any idea?
Basically stores the data for
So basically,
later.
it caches the data here. Okay, so which means, if web server is downloading something or receiving something, okay, it also creates a cache here. So next time it can reuse this cache. And also it is very easy to log all the requests and audit all the requests. Since we cannot write that particular logic inside the application for logging and auditing. So what we do is, so we make it possible in the reverse proxy. Okay. So that is one more advantage. The other advantage is related to the security. Okay. In case, if the attackers are trying to attack the server, so which server they will be attacking? So they will be attacking only the reverse proxy. So which means your application servers are still secured. Okay. Got it? And also these reverse proxy will have a lot of security related configurations. Okay. And you don't have to worry about creating that level of security on the application servers, because it is already implemented in the reverse proxy side.
Uh,
Okay.
Vikram, is the reverse proxy itself a load balancer, or we
Yeah,
use?
I'm coming to that only. Okay. So the reverse proxy can also do load balancing. Okay. If you see here, this is reverse proxy. If it has only one server, then it is one-to-one mapping. Okay. If you have multiple servers behind the reverse proxy, it can also do load balancing for you. Okay. So ideally, load balancing is one of the applications of reverse proxy. Okay. Got it? So now how I'm running this reverse
It's doing a
proxy?
lot of activities, reverse proxy. So should we have a high-end EC2 instance or a normal one is okay?
It's up to you.
Okay, we need to do some kind of monitoring. Okay, got
Okay,
it.
so you have reverse proxy either running as a systemd service, or if you see here, what I'm trying to do is I'm running reverse proxy like a container. Okay. Now the users, they will reach the reverse proxy container. This is the only container that is getting exposed. Internally, this reverse proxy can talk to, other containers. Okay. So this is one use case of reverse proxy acting like a load balancer. Okay. Now coming to the forward proxy. So we said that, I don't have a separate tag. We said that the reverse proxy, just forget about this one. So the reverse proxy is towards your server. Okay. But when you talk about forward proxy, it will be towards the user. Okay. So ideally inside your corporate environment. Okay. So where you'll have thousands of laptops and there is a single or multiple exit points. Okay. Which we call it as forward proxy. Okay. Which means, okay. So here in case of reverse proxy, you are directly talking to the reverse proxy instead of the servers. So which means this reverse proxy is intercepting the server's traffic. In case of forward proxy, your forward proxy is intercepting the client traffic, which means, okay, if you just look at this example, so here the client is talking to the forward proxy is talking to the web server, which means web server is not aware of the client. Okay. So the client information is completely hidden from the web server because your client is not directly talking to the web server. It is the forward proxy that is talking to the web server. Okay. So this forward proxy sits, in front of the user. Okay. So this is ideally used in order to restrict, access to some websites and all that stuff. Okay. Because this forward proxy can monitor the user requests. Okay. If there are any websites that are to be blacklisted, so it can be done at the forward proxy. Okay. So this is done inside the organizations for their securities. Okay. So they can block the employees or students from visiting certain websites like, I wanted to block YouTube. Okay. Within the organization or Gmail within the organization. Okay. So I can block it and forward proxy can block it. Okay. You can also do some monitoring of the employee. Okay. In case, so let's say the website that the user is trying to access is malicious. Okay. So this forward proxy can detect it. And because this forward proxy is making the request, right? This proxy can detect it and it can block the request. Um, you know, that is also there. Okay. So that's the difference. So if you have a server near to your server, I mean, if you have a proxy near to the server, so it is reverse proxy. If you have a proxy near to your user, it is forward proxy. Okay.
So the naming convention usually given from the user client end, right? I mean, the name reverse comes from the from
Server.
okay.
So when you talk about reverse proxy, you should know that it is serving uh, it is intercepting the server traffic. It is at the server side. When you talk
Yeah.
about the forward
Why
proxy,
it's called reverse is something I'm looking. I mean,
because it is sending it is reversing the traffic, right? So it is receiving it and then it is sending it to someone who are sitting behind it. Forward means it is forwarding the traffic. Okay, so that might be the reason, but yeah. Okay, so this reverse,
Forwarding from server to the user, you mean to say?
you can take like that only, but um, yeah, that's how it got the name.
Yeah, seems to be.
Okay. So here reverse proxy can be implemented in Nginx, implemented using HA proxy. You can run it as a container. You can run it as a simple system service. It is up to you. Okay. Now take this example because we are going to implement this example. Okay. So what I'm trying to do is I'm trying to create 3 containers, C1, C2, and C3. Okay, I want to load balance the traffic, okay, from outside. So now what I'm doing is I'm trying to put a reverse proxy here that is also acting like a load balancer. Now what this reverse proxy does is, so whenever it gets a request on port 80, okay, because Nginx runs on port 80, so what it will do is it will basically try to send the traffic back to the backend containers. Okay. Okay, so that is the use of reverse proxy. But ideally, if you look at the Nginx container, okay, so let me run an Nginx container, that is Docker run. I'll directly run it in the
Can single
foreground
instance
mode.
can single instance can run act as a reverse proxy and as well as forward
Yeah,
proxy?
it can do. Okay, I'm trying to run Nginx, but instead of running the web server process, let me just start the bash process. Okay, so that I'm inside the container. Okay, if you look at the configuration like etc nginx conf.t and default.configuration. So the default configuration of nginx is to act like a web server, because whenever someone sends the traffic on its port 80, it is actually sending or setting the HTML. So it is just loading the HTML page. Okay, so this is the default behavior. But what we will try to do is we'll try to convert it into you know what do you say, as a reverse proxy. Okay, so the way we convert into a reverse proxy is, okay, if you look at this configuration, so this is a configuration that we have just seen. Okay, so it listens on port 80 or IPv6 80. So instead of sending the traffic, instead of sending the web server, what we are trying to say is, so we're asking it to send it to some backends. So this is like a target. Okay, now where backend is defined, if you see backend is defined here. So what I'm saying is, if anyone just reaches Nginx on port 80, send the traffic to backend, and the default is I think round robin. Okay, so if you need advanced configuration, we need to refer the Nginx configuration. So what I'm trying to do here is, I'm asking it to send the traffic to hello on port 80, hello 2 on port 80, hello 3 on port 80. So what are all these hello 1, hello 2, and hello 3? So these are names of the containers. Okay, so the names of the containers all listening on port 80. Okay, so if someone reaches to port 80 on Nginx, it has to send the data to these 3 backends. Okay, and coming to that configuration, so we'll be using that configuration. Okay, um so it is given here. So what I have to do is I have to replace the default configuration, so with this configuration. And of course, so here instead of using the IP address of containers, I'm using the container names, which means whenever I'm creating those 3 containers. Okay, I think I given it here. Okay, if I have to create these 3 containers, I need to create them inside a separate network. Okay, then only my reverse proxy that I deploy in that custom network can use the container names to talk. Okay, so I'll show that as well. So let me SSH into one of the instances. So here what I'm doing is I'm trying to run 3 containers, all based on this totem hello world, and inside this mynet. Okay, so which means this mynet should be available. So Docker network create mynet. Okay, so mynet already exists. That's good. So I'm trying to create 3 containers inside that. Okay, so if you see Docker ps-a, just leave about last Nginx. Okay, let me delete it. This is from the previous one. Okay, I just created 3 different containers, all running on port 80. And if you see here, all these containers runs on port 80, but I did not use any port mapping. Okay, because I'm not planning to access them from outside directly. Got it? Clear, yes? So how I'm able to access them? So first I'll try to access Nginx, and the Nginx is trying to send that traffic to the backends. Okay. So for this, I need to have this configuration. So what I'll do is I'll try to create a configuration known as default.conf locally. Okay. And then I will create my Nginx container. Okay. You can see Docker run in the daemon mode. I'm trying to place my Nginx in the same network. The name of the container is reverse proxy. It is running the image Nginx latest. And also we have port map on 8080. If you see here, I'm mapping the default.conf in the current location. Okay, into Nginx conf default.conf as a read-only file. Okay, so whatever configuration that we have just created, I'm trying to replace it. And if you do docker psi-a, you will see that the Nginx is also in the running state now. Okay, now let me try to access your application. I mean Nginx, since it is port mapped onto 80 port on the host machine. So let's try to access it. I think in the security groups it is not open. So let me open in the security group. Okay. So security group is open. Let me take the IP address and try to reach the Nginx. Okay. Now you can see here some container responded. Okay. That's why it is giving its host name. It is written in the Docker image. Okay. So this is not something we have written. If you look at Docker ps-a, so you'll get the container IDs, right? So 37A5. So I think that container has responded. Now, if you try to refresh this same URL, okay, you will see that another container responded, which is OF6. So what is OF6? This one. Okay. Now let's try to refresh it again. See, another container responded. Got it? So it is doing the load balancing, right? Round robin. Clear, guys?
Clear.
Okay. So this is how you implement load balancing with Nginx. Okay. So you can also do with HA proxy. You can also install Nginx as a normal system service, and then you can configure the reverse proxy. Okay.
Vikram, what is the use of that bind volume in that command?
Yeah, we have this configuration, right?
Okay, okay, okay.
That configuration we have saved as default.conf in our local machine. I mean, in that machine, in the
All
current path.
instead of copying, you are doing this, right?
What I'm doing volume mount to mount that conf file,
Okay.
and that too has read-only mode.
Vikram, hello.
Yeah, yes, please.
So if I want to implement the same using the cloud load balancer, let's say AWS, ALB, or Classic or Network. So
Mm.
since all the containers are running on a single EC2, I give target as one EC2 here. So will that load balancer between the containers?
You mean to say this Nginx?
Instead of Nginx, I'm using a cloud load balancer.
So if you're using cloud load balancer, then it should have an entry point.
Yes.
Okay, it should reach the server on some IP, on some port number, right?
Yes, right.
So in that case, what you can do is, this is not the right way. So you can take C1 and expose it on 80, C2 expose on 81, C3 on expose on 82. Then you have three ports, right?
Yes.
Then you use all of these as targets. So one target is 80, other is 81, the other is 82.
You meant to say I need to use NLB then for ports.
Yeah, you can also use that. But if you look at, in ECS, right? So when you try to create a service that has multiple replicas of your application, so there automatically a load balancer gets created in that service. But if you have to do for the same thing, you need to, use a different approach.
So ideally, I need to run the containers on different ports here if I want to use cloud.
Correct. Yes. Because containers by default, if you see here, I've not opened them on the host. Okay. I'm using Nginx as the entry point.
Yes.
On top of Nginx, if you want, you can put ALB and then have a single entry point to the Nginx. So in that case, target is only one for your ALB. Okay.
Okay.
But that particular target, again, it is splitting the traffic. So you will see
Two
the
load
change in the traffic. Yeah,
Yes.
load balancing is there.
Okay.
Okay. Now coming to the DNS round robin load balancing. Okay, so what is the use of this is, this is also one type of load balancing where, a single DNS name. Okay, let's say I have a DNS name like www.google.com. A single DNS name will have multiple IP addresses as a mapping. Okay. So now when someone talks, basically to that DNS name, so instead of having one IP address written, so it will have multiple IP addresses written, and your client can just take one single IP address and then talk to the server. Okay, so let's say I have www.google.com. Okay, and this has, instead of one IP address, it has two IP addresses. Now as a client, I'm just talking to google.com. Okay, since directly I can't talk to the server with its name, so this google.com will return the IP address to me, right? Then I'll be able to talk to the IP address, correct? That is called DNS resolution. Now, instead of returning one IP address, it usually returns the multiple IP addresses to which a single domain is mapped, and the responses can be rotated with every query. Okay, so first time when I talk to google.com, it might return IP1 first and IP2 second. Next time it might send the IP2 first and IP1 second. Now the client has multiple IP addresses. Usually the client will select the first one. So in this way, what will happen is, so you have a single entry point, but there are multiple servers behind it. And anytime you're talking to a different server here. Okay. So for example, so you can implement DNS round robin load balancing with, within Docker using -- net alias. Okay. So the meaning is, see here, I have the same my network or something. So I have three containers, C1, C2, and C3. Okay. Clear? And let's assume I have one more container called D. So now tell me, if I have to load balance my requests, see all these C1, C2, C3 are individual containers, and D is also an individual container, all running on a closed bridge network called MyNet. If I want to talk to C1, so what will I do? I'll use the C1 as the host name, right? Correct? Guys?
Yes, Vikram.
Or if I have to talk to C2, it is C2, it is C3 for C3. Okay. So what if I have to have a load balancing where I won't directly talk to C1, C2, and C3. I'll use a single entry point name. That entry point should actually, talk to different containers. Okay. So I'm not planning to put a load balancer or reverse proxy here and then talk to the reverse proxy. So here we have a concept known as, see, if I'm saying C1, C1 will only resolve to C1's containers IP address, C2 for C2's containers IP address. But I can add an alias name to each container, a same name. Okay, I'm calling each one as web. Okay. So this is an extra name, a common name. So now for the same common name called web, there are three containers behind it. So if I'm reaching this web, my client or whatever the service that is talking to web, it will get the IP addresses of all the three machines, and a client can choose which one it needs to talk. So ideally it will take the first one. Okay. Next time when you talk to web, the responses are, jumbled. So this time you're talking to C2. Okay. Got it? Now using a DNS name, net alias. So what I'm trying to achieve here, I'm trying to achieve a load balancing that is based on the DNS name. And again, it is round robin because you are connecting to a different service container every time. So this is DNS round robin. Any questions?
Yeah, but it doesn't consider the load, right, on the containers.
No, it considers this load.
Okay, so
Okay, so
it
for
takes.
example, um, I did not use net alias. Um, let me show you one thing. Okay, I can take the same tutum as the example. Okay, but what I'll do is I'll first try to remove all the containers. Okay, I just removed all the containers. Now I'll just create this hello one container, same network, that is mynet, but I'm going to give an alias name to it. Okay, this alias name I'm calling it as web. Okay, so I created a container hello one. Okay, see, container name should be unique. Okay, but net alias can be seen. See, what I'm trying to create is here, I'm trying to create 3 containers. Okay, hello 1, hello 2, and hello 3 within this mynet network. And they all have something known as web. Okay, got it?
Yeah.
Yes.
Now what I'll try to do is I'll try to, curl. Okay, so curl has, I think, a different image, curl images slash curl. Okay. Um, so what I'll try to do is I'll try to now docker run -rm. The name of the image is curl images slash curl. Okay, so this will actually have the curl utility. And I'm trying to curl, I should also be in the same network, right? -net or -network, both are same. I'm trying to use mynet only. 1 second, guys. I should use after -s. Let's say I wanted to connect to hello one. Okay. So which response it is giving? It is giving 210 something like this, right? It is the same response that we have seen here, the HTML page. Right. Clear? Guys?
So
Yes,
you are saying,
Vikram. Yes.
so, so you are saying that this curl images is container acting as a proxy.
No, no, no. See, this is just like any other container which is running on the network, mynet. It has curl utility inbuilt. I'm trying to curl that particular container. It is like you're using curl in silent mode. It's like HTTP. The name of the container is hello one, and the port on which it is running is 80. I'm talking about this.
Okay.
I'm actually trying to connect to the individual containers like this. So every time I'll get the same response. I can talk to the hello to container. So this is going to respond with its own data that is there. Okay.
Okay.
But there is no load balancing here. If you see, if I just take this curl container as another microservice talking to an application that has 3 instances. Okay. Like hello 1, hello 2, and hello 3. But that particular application has to talk to the individual containers for load balancing. But why will I talk to the individual containers? Right? In order to talk to the individual containers, I should know their names and all. But I have assigned a network alias known as web. Okay. Now, if I try to reach that network alias name, okay, my service is going to get responses from all the containers because this web is nothing but an alias name for all the 3 containers. If I'm trying to reach web, that request gets forwarded to at least, to one of the IP addresses. Okay. If I try to run web, okay, you will see that responses are changing. right?
So how this is different from reverse proxy? Like both does the same, right? Like
Does the same, but we don't have the reverse proxy here, right? So this is DNS round robin load balancing.
uh,
Okay,
so
so this is only possible, if you can map multiple IP addresses to a single DNS. Okay, so this is useful if you don't have any reverse proxy setup, but still you want the reverse proxy kind of configuration.
but within internal only can be, it cannot be external, right?
It can be external. See, currently, what is this web? This is just a DNS name. It is getting resolved to your container. I mean, it is internal to your Docker host, but it can also be, your general google.com URL as well, right?
Okay.
It is same thing. All I'm trying to say is it's a DNS name, but the DNS is responding with multiple IP addresses. Okay, so usually client will take the first one.
Okay. I mean, if we have NetAlias, then why we use reverse proxy again? I mean, for a load balancing and stuff.
So there are multiple techniques of load balancing. You can use a service. DNS round robin is one more technique.
Okay. Is it similar to that Kubernetes service actually?
Yeah, Kubernetes service also acts like a load balancer. Uh, yes, so this is similar to Kubernetes services only. Yeah, so service name resolves to all the backend ports. So here, a single DNS name is resolving to multiple IP addresses. It's the same concept.
Okay.
Okay.
But in real time we won't use this, right? We have a
You can
dedicated.
use this. See, let's say you have multiple servers. Let's say you have configured Route 53. Okay. So for a single DNS, you have multiple, single A or AAA entries. Okay. Let's say you have a single domain like example.com, but there are multiple IP addresses configured for the same domain. Like you have multiple A records and multiple, AAA records.
Okay.
Then what is that? So when someone is trying to reach your example.com, so you have multiple IPv4 addresses assigned, right? So they will get all those IPv4 addresses back. And then, they will connect to one of the IP addresses in that list.
Okay. So like it is scalable and manageable, right?
Yes. At the Route 53 level, you can have multiple A records, right? So that concept. But here, internally, when you're using netalias as the command, okay, so it is actually trying to create multiple DNS entries for this web. So for this web, C1 is also a record, C2 is also an A record, C3 is another A record. So that's why when you're trying to reach web, it is actually sending the information about all these three containers uh, to that single DNS query.
Right.
Okay. So this is one of the technique. This is there. I wanted to cover.
Vikram, in this case, if I create a record in R53, should I give the public IP of my instance EC2?
Yeah.
And I'm yes.
So you have to give something which is resolved by Route 53.
Okay, so that's the public IP of
It's
EC2.
not. Yes.
For that,
Anything which is publicly available.
so if I give www.dma.com and give my public IP, internally I have NetAlias, will that result to multiple IPs?
See, NetAlias concept is only till Dockers.
Okay.
So for Route 53, you can configure DNS round robin. If you search internet, you'll.
Yeah, there is multiple IP address.
Yeah.